Hello everyone, this is Miss Chelsea and today we'll be finishing up properties of waves. Our current standard is S8P4E, which is to analyze and interpret data to predict the patterns in the relationship between density of media and wave behavior, i.e. speed. Before we get started, let's review a little vocabulary. Electromagnetic waves are waves that can travel through a vacuum, such as outer space. They do not require matter to travel through. The matter that a wave travels through is called the medium. On the other hand, mechanical waves do require a medium. Keep in mind that the medium that a wave travels through can also affect its speed. All electromagnetic waves will travel at the same speed in a vacuum. However, if they use a medium to travel, then their speed will be affected and they will slow down. So electromagnetic waves go slower when there's matter than when there's no matter. Sound waves, on the other hand, require matter to travel because they are mechanical waves. Sound waves travel faster through liquids than they do through gases because the particles in the liquid are closer together, meaning it is easier for the particles to bump into one another in a liquid than a gas. Light waves travel faster in air than in water because the particles are further apart in gases than in liquids. And particles of matter actually slow light waves and other electromagnetic waves down. The denser the particles in a medium that an electromagnetic wave uses to travel, the slower the wave will move. This is why light will travel extremely slow through a solid. This is in contrast to sound waves, which move faster the denser the material. Before we look at ways to change the energy of a wave, let's review a little bit of vocabulary. The amplitude is the displacement of the wave. It is the distance from the rest position or the central position to the crest or the top of the wave. It can also be defined as the distance from the rest to the trough or the bottom position of the wave. Frequency is the number of waves cycles that pass a given point per second. Wavelength is the distance from a point on one wave to the same point on the next wave. So wavelength can be measured from crest to crest or from trough to trough. Now, greater amplitude and greater frequency can mean that a wave has a lot of energy. So high amplitude, that means the particles are moving more, that's high energy. High frequency, that means the particles are moving more often, mean that the wave also has a lot of energy. So, for example, if there are two waves with the same wavelength, but one has a greater amplitude, that wave will have more energy. Alternatively, if two waves have the same amplitude, but one has a greater frequency, then the one with the greater frequency will have more energy. Keep in mind that a medium does not always transfer all of a wave's energy. Particles do not always return to the same resting position once a wave passes through the media. This can cause some of the energy to be lost. Go ahead, pause the video, and try the checkpoint question. Why does sound travel faster in water than in air? Well, it's easier for sound to travel when the particles are dense and closer together because they're more likely to bump into each other. That means that sound will travel faster in water because it's denser. Now, let's think back to those big explosions in some movies about space. What would be true about those explosions if they were to really happen? And what isn't true about what the movies show you? Explain. Go ahead, pause, and try to answer this question. Well, if an explosion were to occur in space, you would not hear it because there's no medium for the sound waves to travel. However, you could see the explosion because light is an electromagnetic wave and can travel even without a medium, so without the presence of matter.